Okay, thank you everybody. And thank you to Farms.com for having me back again this year. This has been my fourth time presenting at the Precision Ag Conference. My name is Chuck Baresich, General Manager and one of the owners of Haggerty Creek Limited. And Haggerty, I got a picture of it here on the screen, is we're a customer service business. We supply crop input and grain handling to our customers in the 4 counties area. Lambton, Kent, Middlesex, and Elgin, kind of, where they intersect. And we named our business Haggerty Creek after the Haggerty Creek, which is a man-made drainage system. And all of our customers' farms are drained. They're all connected to the Haggerty Creek with their field tiles. So we thought it was fitting that we had a connection to them all, and that's why we chose the name. My brother Justin and I are also primary producers, corn and soybeans. We have a long-term no-till cash crop operation of just over 3,000 acres in the immediate area. And Haggerty Creek got involved in the precision ag business back in 2004, providing a full range of solutions, from soil mapping and sampling, application equipment, and guidance equipment. Our primary product is supplied by Raven Industries, but we also support Trimble and John Deere and others based on what our customers ask of us. And I'm going to play a little video here. So getting your farm ready for autonomy. I guess it's situations like this one, riding in this sprayer, that have got me thinking about autonomous agriculture. The sprayer's running the boom on its own. The computer's controlling all the chemicals on its own, recording what it's doing. And I'm sitting here with my cell phone just videotaping it. The sprayer's driving itself up and down the field. And the question always is, why do I need to be in this cat? Why am I in here? What else could I be doing? Skilled labor is scarce. And so that is the thing. And so autonomous equipment, it seems to be, delayed. Where is it? The sprayer that I was driving was a 2008. It was using, so that's a 12-year-old sprayer. It's got 10-year older than that auto steer technology. So I think the technology is here to make autonomous equipment, which is not quite here yet. And I think one of the issues about why we're seeing some delays is maybe people are concerned about efficiency and capability. We're looking at, are we running smaller machines to save weight? Are we going to have less acres per hour? We have to transport that machine on a trailer to various fields. I think there's been some market demand issues. When you're going autonomous, stuff has to be pre-planned. And in the moment decision-making, can be very efficient. And are we as farmers just not ready for this? This is some of the questions that I have as I'm sitting there riding around in the equipment. And as an example, when you look at this sprayer here, farmers want efficiency, and large equipment is designed to be efficient. It's not just for large farms. Small farmers need to be efficient as well, because their labor is more scarce than a larger farm tends to be, especially if they're, have second off-farm jobs and things. And as an example, it's, from an autonomous equipment perspective, it's been difficult to compete with machines like this Agrovac Endurance. It can spray 327 acres an hour. And for an autonomous machine to compete with this, it can be difficult. And where the efficiency is gained is not just in the acres per hour, it's also in the moment decision making. With this sprayer, it comes with a built-in human, that is your onboard computer, that is making those decisions about backing into corners, going up and down the road, where to drive, where not to drive, those kinds of things. So in my comment piece, about autonomous farming and getting ready, this is where we're coming from as to, kind of why we're not here yet. And making these in the moment decisions really affect autonomous ag. Now, when you look at it though, are those decisions more effective? A lot of the times when we make a decision in a hurry or quickly, the decision we're making is to just do what we've always done. when you're in a pinch and you got to get something done, you go back to your default position. And what large equipment has done for us, it has allowed us to do what we've always done, just do it faster. Um, Not that this is all bad things. If you look at what it took to get us here, some of the issues we face with is to get efficiency and speed to get things done. But we also want to care about what we're doing and have accuracy as well. And all of those terms are all good terms. Like, it's not that efficiency is bad, it's not that speed is bad, but accuracy and care is also good. And I have an image of one of our farms up in the corner of the screen. And large equipment has made us change the way that we farm. So we actually shape our fields around the equipment that we're using, not necessarily around the farms that we're farming. And on this farm that's here, like, there's 5 different soil types, maybe more, on this piece of equipment. The fence rows are taken out, the corners are squared up, all these kinds of things. And this is being done not to get the best crop that we can possibly get, but to get, to be more efficient with our equipment. And when you have large equipment, sometimes there's issues. Some farmers will miss a yield opportunity on parts of a farm waiting for another part. And some farmers will damage parts of their field because they can't wait for the proper timing. It isn't that farmers don't care or don't know about what they're doing. They deeply care, but sometimes there are other pressures force decisions to be made, but they aren't always necessarily the best. So when you're getting ready for autonomy, part of this is a mindset change. Autonomous agriculture is it's more than just equipment and robots. It's actually about thinking about, what does a farmer actually do? And where I got this from, I made a presentation to a grade 7-8 class about autonomy and robots and technology and farming. And some of the kids were quite upset that they were not going to be in the tractor driving it, that a robot might be driving that tractor, or that a robot might be milking the cow. And it really caught my attention that does actually driving the sprayer or milking the cow or driving the cow, does that actually make you the farmer? Or does making productive use of the land base make you the farmer? And I think this was an interesting thought that came up with that. So as I was thinking about this presentation and thinking about getting ready, I thought I should mention that. So when we're getting ready for autonomy, one of the things that come out of this is, as a farm manager, what are you trying to achieve? If the territory is, what are your objectives? If that's the territory, and then what is your outcome? What is that outcome that you're trying to get from that land, from the crop, from your operation? And then within that territory, you're going to have a set of parameters that will frame it. So, and that will be like the map of the territory. So this would be, profitability. Can I maintain profitability doing what I'm doing? Can I maintain soil health doing what I'm doing? Can I adapt to future crops? So as we are, thinking about farming and where farming is going, these are a few of the, this is something that I would like to think about as an outcome. So it's not just about, sending a robot in the field to do a task I'm always doing. What is the outcome? What do I actually want to achieve with this? Because things are changing all the time. Land prices are going up, consumer trends are affecting our production methods. Chemicals are always up for debate, and it doesn't matter whether you agree with this thinking or not. As farming, it's just the fact of life. Like, I'm a business owner who sells chemical weed control, and there is high pressure to eliminate chemical weed control in production agriculture. So that concerns me. And rather than putting my head in the sand and saying, we are going to carry on as business as usual, is there something with automation and robotics that can help us move along that change. So all of this is related to getting ready. And so then is automation a fit? So once you've got a clear sense of your outcome and what parameters you're trying to maintain, are there some things within the parameters that limit your ability to achieve your outcome? And can autonomy help bridge that gap? Are there some regular repeatable tasks that allow you to use an autonomous machine to do that? And so this is some of the things that get me interested in robotics and get me interested in automation, moving forward to, how do we change this production practice? Some people are calling this, Perplant farming is what they're calling it. And the reason why I'm interested in this, and part of the discussion of perplant farming and autonomous agriculture, is they tend to go hand in hand. And we've seen that, corn yields in the US have improved a lot, about 2 bushel per acre per year. In our own area, we've actually increased our own corn yields by more than that, keeping in mind that we come from a lower average area, so it's a little bit easier to do. But what's interested me in doing research for this presentation, that in 1985, the theoretical corn yield was suggested to be at 1,300 bushels per acre. The record holders that are out for corn right now, and I talk about corn because I like corn, are showing us that we're only at 50% of that. But as an industry, as a per field average, we are barely 20% of that. And can perplant farming and automation get us closer to the theoretical yields? I've had some discussions with Sam Watson from the Small Robot Company in the UK, and he's echoed the same comments with UK wheat production, suggesting that wheat yields in the UK have a theoretical yield of close to 300 bushels per acre, but the commercial average is around 126, which, just like corn, is about half potential average. So it's not just a North American phenomenon. This is something that is through various entities or various parts of the world. So perplant farming is trying to emulate researchers and laboratories on a larger scale. And I think this is a path of getting crops to higher yield plateaus. And they sent me a few slides, and I'm just going to burn through them pretty quickly here, believing that they'll be the sense. The one slide that I liked is this one, showing that it's not my slide, but it's a good discussion point talking about, what the fourth ag revolution will be, and whether it is moving from heavyweight to lightweight equipment, moving between mass application and precision treatment. So this part of getting ready for autonomy is what is the next revolution. And interesting, in the UK, the estimate is that 85% of UK farmers are not viable without subsidies. So obviously we don't want to emulate that, I don't think. I think this is something that, we need to improve. And change is ongoing. We've had lots of changes over the past, even in my own short farming career, and I think autonomous agriculture is just that next change. So, with current labor issues and with all the other issues, autonomous machines, they have a place for us. Now, that being said, you can't start by just saying, I'm just going to go buy a robot. There's other factors that are going to get in your way. And these are some of the consideration points that we had in moving forward with our autonomous stuff. What about my old machinery? Who's going to watch the robot? How do I supply the robot? The key one at the bottom is, will it do the same job or better than what we were doing before? And I think that's a key piece. So when we talk about the move to precision and perplant farming and these kinds of things, like, obviously we want a machine that will do a better job than what we're doing now. So one of the things we started with is a dot machine, and I'd like to thank Auger. The Auger took this video for us, showing the dot with a spreader unit on it. And I started with the spreader because this is a pretty universal application. this fertilizer spreader can, it has full section control, and I can monitor it remotely and these kinds of things. And so we had some pretty good experience using the autonomous robot, trying to figure out, again, one of the things we forget about is that people will ask me, well, who's watching the robot? And doesn't that type of person watching the robot? And I said, well, yeah, it does, but it's not any different than having the person driving the robot actually sitting in the seat. The difference is that the person who is watching the robot can be also watching the kind of job the robot is doing. They can be talking on the phone to a customer. They can be doing other things. Some of the other stuff that we found is, how do we load the robot up? What is the most effective? Can we actually get it to the field in good time and transport it from place to place? And these were things that we had to figure out. I know the first day we had the dot unit, we thought we'd do 400 acres, and we did about 100. Just because we had some logistical issues trying to figure out how we actually, how we simplify things and work with it. So as time went on, and we got pretty good at it towards the end. You can see it dodging a hydro pole here, going around. So it was an interesting experience this spring. One of the things that we learned about when we're getting ready is that we weren't as ready as we thought we were. Here we thought we had 70,000 acres all mapped out with boundary maps that we could just drive the robot out and away we go. The issue is that what I'm showing on the screen here is Dot's path planning tool and showing you where the robot is going to drive. And so if you can see my cursor or not, you can see the different paths, obstacles it's going to hit, waterways, and holes in the field. And so these are things that we take for granted. And when you're a sprayer operator or you are a planter or whatever, these are all things that we just deal with when we get there. The robot cannot take that for granted. Like it just doesn't know. So one of the things that we learned getting ready is that you need to map your fields out for geofencing, where the robot can go and not go. You cannot rely on old maps because, believe it or not, posts move, trees expand, and things change. So the robot, can handle some of these things, but not really. It can also be tricky trying to generate sub-inch field boundaries, trying to get RTK signals underneath big maple and oak trees. You can't just assume that you can just run out there that day and get the map. Sometimes, signals fail and they don't work. We also needed to figure out what to do with the corners of our farms. I think we have to assume that for the time being, most autonomous units are not going to be able to back into corners, at least not right now. The smaller machines might have a better chance, but the bigger ones will not. So we have to make a choice between 100% coverage or 100% guarantee of machine damage, one or the other. I think those are things that, as a farmer, we need to start making those decisions and choices. And here's one of my farms as an example, that has lots of trees and weird areas and points and corners. So my question would be, when I am planting and scrubbing all the tree branches all along these edges, one of the thought processes we had is, why am I actually worried about these areas? Nothing grows there anyways. The yield is basically zero. So why am I trying to force my autonomous machine into those areas for no reason? And that is something that is, we didn't really consider moving into this. Another piece would be planning laneways for ingress and egress for our autonomous machines, loading and staging areas, planning out the direction of travel speeds, management zones, different soil types. There's a lot of things that we just take for granted, or that the operator decides when they show up, that the robot just doesn't know. So these are all things that involved in planning. And in some of the fields that we planned with the dot unit, sometimes it took us half an hour or 40 minutes to try to figure out a good path planning. Sometimes it took us 10 minutes, or 2 minutes. So it just depends. So one of the things we learned is let's just not make it more challenging than it already is. Obviously straighten up what you can and ensure your good access points. Get rid of that old tree stump. We had some customers when we brought the robot out that forgot to tell us that, oh yeah, that low ground washes out in the bottom every year, and I forgot to fill it in. So after you bounce through those, a few of those, so let's fix our fields up while we can, and then let's consider having maintenance strips around our wooded areas to allow for boom and attachment error, because there's going to be some. So rather than planting this, why don't we leave a strip that's wide enough for a small sprayer or for a mower or something to deal with. It's not going to cost us anything financially, but it's going to save some headache with your autonomous equipment going forward. Another example that we have been playing with here at Haggerty is with soil sampling. We use a soil optics sensor, and the soil optics sensor, the reason why it fits well for an autonomous machine is that you have to drive the same speed at the same distance over the field, and changing your speed changes the resolution of your coverage map. So driving too fast, you lose resolution, and driving too close to one side makes an issue as well. The other thing is driving a John Deere Gator up and down the field is a tedious task. It's slow, it's dusty, it's hot and cold, and sometimes all on the same day. And it can limit the amount of acres you can cover in a day, and the staff can do nothing else because it takes your full attention. So one of the machines that we got for doing this is the Romeo Unit. And so this is what it looks like. It's just a small autonomous robot that carries our soil optics sensor for us. And you can see it there on the front. And this little robot, can run for 8 hours, can run up to 8 miles an hour, carry 1,000 pounds. Now, it can do more than just a soil optics sensor. We do have some other attachments for it that we have been experimenting with to work with it. It has, interestingly enough, even though it's small with a 60-inch track spacing, the same issues that we came across with the DOT unit fit with this unit as well. Knowing your fields, knowing when you're going to drive, direction of travel, all these kinds of things are related. And I guess what we're doing with this here, the goal with this here is to double our acres per hour in a day. The only difference with the Romeo unit compared to the DOT is that because it's so small, we can leave it alone while the staff are doing other things in the field. So one of the other pieces for getting ready to autonomy that I have kind of felt were important is to try to standardize as much as we can within our farming systems. And autonomous equipment does not like variability. And so we're going to have some agreement when it comes to automation. I've heard lots of people say that, what you're doing on your farm won't work on my farm. But I think it's a lot of that has to do with farmers each having their own idea that what they're doing is the best. And we're going to have to work on changing that. So standardizing things is going to be key. Working with the Raven auto cart for an autonomous grain buggy, having different size trucks and weird access points and all this kind of stuff just does not work with an autonomous system. So that's just something that we're going to have some agreement on. And I think one of the pieces on this slide, as we go through, let me just skip through this. The last piece on getting ready for autonomy that I think, just in the interest of time, that I want to get on towards is on the data piece. But the other important piece on autonomous is the whole sharing of information and sharing of data. And I'm going to go back one here. What Small Robot has done is they have built an AI system to collect all the data. And what's interesting about their approach is that they want to understand plants, what the plants are doing, not the field or not the crop. Like, they're looking at individual plants, which I find very interesting to their approach. And we've also played with other companies' technology on, spray records and autonomous. So the next step for us in our path to autonomy is to use these AI systems and use these sensors to help some with the predictive modeling. And we've used the tools to count populations, to identify weeds, identify pests, suggest spray timing. And this will make the use of the autonomy a lot easier. And I guess my last slide is going to be on data sharing. So if we're going to have autonomous equipment, if we're going to try to improve yields using this, we're going to have to be more willing to share data amongst ourselves. And what this is going to turn into is that if we share this data amongst ourselves, each plant becomes its own test plot amongst multiple farmers amongst a larger area. And I'm quite excited about that as far as what it could do for our yields and what it could do for our potential. And some sort of standardized data collection sharing platform, I think, is going to be key to this, to get us ready to move to that next level. I think it's, from my own perspective, Chuck and Justin Baresich's farm data is kind of worthless to anybody individually. But I think as we move to having more shared data, I think that's going to be the key to some value to farmers. That's everything I had on my slide, and I'm going to just stop my screen share here, and we'll see if anybody has any questions.
All right, thanks a lot, Chuck. So we'll just do a really quick Q&A. We have a couple minutes left. So one question. Do you envision autonomy being the standard on farms in the future? Like further down the road, do you think this will completely change the framework of farming, and a lot of farmers are going to, it'll be the standard for farmers to adopt this technology? Do you think that's the route we're going?
I think so. I think to some degree, I would say yes. And I think if we look at in the near future, I really see some autonomy coming on high value crops and lots of passes and this kind of stuff. I think we're going to see that adapt more rapidly. I think on some of the larger farms where some of that equipment that I showed you, I think it's going to take a little longer. And as an example, I kind of glossed over it in one of my slides that there's some large equipment in here that is so underutilized on farms. Like we have so much capacity equipment wise, it's going to be hard for the autonomous stuff to compete with that in the short term. I think maybe 10 years from now, I think you'll see a lot higher growth on even the large farms. But I think we're going to see it on the mid-size and the higher value. I think we'll see an explosion of autonomous agriculture happen here in the next 2 or 3 years.
Interesting. All right. So next question. If you aren't going to seed right to the field edge, how are you planning to manage those unseeded zones to prevent weeds from taking over? So that's a question from Daniel from Olds College.
So my thought process was, in some of our farms, is that we are going to create about a 6 to 8 foot wide strip along those tree edges that we'll just let grow up into stuff. And one of the attachments for the Romeo unit is actually a small sprayer, and it can just follow the track along that path all on its own and just spray it down with something that will control everything but the grass and just let the grasses grow up. That is actually what my plan is, if you're curious. It's actually what the old timers used to do back 50 years ago.
Okay, we've got another question here from Tamazan at Reading University. How would this work for small to medium-sized farms or farms in less than marginal landscapes?
So I actually see a lot of interest from small to medium-sized farms because they don't have the critical mass to have full-time employees. And they also don't have the ability to hire someone temporarily just for their seasonal work. And so where this fits in is the robot becomes almost the third hand. It becomes that person that can do a task, while the landowner is, sleeping, resting, going to work, or these kinds of things. That's where I see the fit for autonomous vehicles on the smaller farms. Then on the marginal farms, on marginal land, this is where using small machines to till or plant or whatever can be effective. Let's say we have side hills that are too dangerous to traverse with a big machine, or you have poor drainage or poor soil structure that you can't support a machine that weighs 50,000 pounds. This is where using these small autonomous robots, I think, could actually not only bring that land into production, but actually protect it as you're farming it.
Okay, we'll finish up with one more question here. Marcus from Houston Independent School District. Do you see cost of tech as the main barrier to adoption?
I don't think so. I think just like anything, I think initially maybe, but all equipment technology is expensive. So I would say that the autonomous tech is not any more expensive than anything else. In some ways, it's a little bit cheaper, and which makes it somewhat more accessible. The other thing about technology is that it tends to become cheaper over time. So as more gets adopted, I think we will see the cost come down. The other neat thing about using multiple smaller machines is that it should allow us to lower, if an equipment manufacturer like John Deere can go from making one large sprayer to making 20 little sprayers, it actually helps their processes, which lowers the overall cost per machine. I hope.
All right, thank you, Chuck. So we'll have to wrap it up there. Great presentation. This is some really interesting stuff you've got going on here. Thanks for sharing your experience and knowledge about the farm automation. Pretty interesting. And it was great having you here. We really appreciate it. Thank you.
All right. Thank you very much.
And so if anybody has any more questions for Chuck, you can reach out to him in the networking session of FeedLoop or reach him by email.
Great.
Thank you, Chuck. Bye.
Bye.